So I want to invite here our next speaker, and this is lead software engineer at EPAM, Joao Paulo Sanchez. Joao, welcome to Javod. Yeah, thank you very much. Let's start. Good luck. Stage is yours.
Okay, thank you, guys. So we are here to talk about virtual threads. I know that you haven't been heard about these on yesterday about this new feature of Java, but we're gonna go deep on this virtual threads new feature. But let me introduce myself just for a moment. I'm Joao Paulo Sanchez. I'm from Brazil, São Paulo. I have been working with Java for like 20, 20 years, more or less, 13, will be 13 in this year. I'm working as a lead software on PAN, and I have worked with clients like Google, like SLB, and others. But I have been working on companies like IBM before, Leroy Merlin. So it's been a long career so far. Let's begin into what is important. What is going to talk about today? So we're going to do a brief introduction about what is the virtual thread is, and then we're going to explain how the threads work today without the virtual thread. What is the true problem? What happens with the actual scenario of the JVM? What is a thread blocker? And what is awaiting? The first solution that JVM gave to us, the Java completed filter, and why it doesn't work well. And then we're gonna talk about the virtual threads itself, how it's work, and then we're gonna talk about how a good use of it and when these virtual threads do not work, because we have a scenario that virtual threads don't will work well. So let's begin with the introduction. The virtual threads were introduced on the Jeep 444 by Alan Bateman. I don't know if everyone knows what a GPD is. It's a Java Enhancement Proposal. It was a proposal to create a feature that will use better the hardware, because one of the problems of the JVM today is we not use all the resource we have from the machine, because we have one characteristic from the threads is one thread by resources, by request, sorry. And this one thread by request block the thread and block the thread from the CPU. And then we don't use the full resource that we have on the machine. We lost a lot of time and resources. This is the proposal that Alan Bateman sent to us that will resolve this problem. But first of all, let's discuss about the problem. Let's understand how it's works today. Okay? So today we have the thread by request. What is a thread by request? Let's imagine you have a Spring Boot application. You have a request came from users. Each request from the users will create a thread on the Java Reaper memory. And then this thread will communicate with the OS thread, and the OS thread will communicate with the CPU thread. And this will be a problem. But let's see a picture of it to understand better. So this is the JVM. First of all, what we have here is the run. There's going to be a request. So the request will create a stack. What is a stack? A stack basically is a queue, a FIFO, first in, first out, of commands. So for example, you do a request for a get user. The get user will access the get service, the entity, and going to the database. So the thread will execute these full commands. Some of these commands has external dependencies like consulting a database, consulting uh, a API, for example. So imagine this is all a request from users. And these users will create threads on the Java heap. So what's going to happen? The JVM will say to OS thread. Remember, the JVM was created to be out of the OS. Is not fixed on the operational system. So the JVM will manage the thread of Java for the operational system thread. So the JVM will create for one thread, and they will create a OS thread. And then the OS thread will truly execute the command on the CPU. They will hold the CPU, a core of the CPU, to execute the command. And then when this finish, it's gonna say to the S thread, it's finished, and they're gonna say to JVM, is that finished? But what's the problem here? The problem is, let's imagine you have an API call that will take like 3 seconds. So this thread will say to the OS thread to execute this API call. And the CPU will do that. But when we execute these 3 seconds, the thread is blocked. This whole process is blocked. So we take 3 seconds of loss of a core of a CPU. So what's going to happen? So exactly what I say. For example, this is a database. It's a block IO or API call. When you do a query, the thread is blocking, waiting that the B response. But the thread is there doing nothing. And what can happen? So let's imagine a scenario. We have a lot of requests from the users, but we have a long query that is take too long to respond, and you have a lot of requests, and your thread pool is, we have threads waiting because we don't have more CPUs, because the CPUs is full executing the query and waiting for the query response. But we have some threads waiting, and these threads waiting going to the heap memory. In the heap memory, it will hold all these waiting threads, and the heap became longer and longer and longer. Then we have this problem. We have out of memory because we have a lot of threads waiting because we don't have CPU to execute that. And then we have an error and your application crash. That is happening more than you can imagine. For me, for example, I saw this happen in production like 4 times because a long query take all the resources, and we don't have more CPUs to executing threads, and then out of memory because our thread pool is full. This happens a lot. We have a solution for that. We have on the Java 8 and the Java 9, we are introduced to the Java functional, and the Java functional give it to us the Java async that is calling Java completed feature. Java feature. This Java feature gives to us an async solution. Basically, we don't have to wait. This wait time we have before that is waiting the thread to respond, to execute another. This don't happen anymore because this is the executor service of completed feature will take a queue of blocking and a queue of executing threads, and then the thread will be executing, when, for example, we block a thread like we have before here, they're gonna move this thread to the blocking queue and gonna get another thread to execute on the CPU. So the CPU is not more just waiting. They'll be executing something always. So always will be executing something. We don't have more idle times on the CPU. It's perfect. So this is the solution we needed. But we have a problem here on the Java future. Is the complexity. Because Java future will need to change a lot of things. It's a completely a different way to programming from the Java sync to the Java async. For example, today we have the that is completed future the Java the Spring Flux, but it's a completely different way to do we have to the applications today. And the case is here we need refactoring, and refactoring is complicated because normally it's take time and money, and it's very difficult to someone approval that or some company approval that to refactor everything just to fix a problem of delaying of to use a better research because it's cost a lot. And we have another problem, it's changed a lot. So your team, your teammates is totally used to programming Java sync. So to change to a different way to use functions, to use async paradigms will be a very hard and will take time to everyone to learn that, to start using that. So we have a big difficulty to use this solution. Because of that, on Java 9 and Java 8, no one was using because it's very complicated to change everything. So in Java 19, we have the G 444, the virtual threads. But what's the proposal of the virtual threads? The proposal is that approach don't will require any code change. So the virtual threads, to use that, you don't need to touch on your code. The change will be on the JVM side. The JVM will change all the way the managing the threads. So remember, without that, basically one thread, Java is one JVM thread was one OS thread, and this was one core. The virtual threads change that. Will change the way we do this manage of threads. But let's understand exactly what is changing. Do you remember, do you have the JVM threads? The JVM threads that is communicate with the OS threads, it will change to the platform threads. So the platform threads basically will be executors. Do you remember that I said on the Java competitive feature, we have the executor service. Basically, the platform threads will be exactly the same as the executor service. And the virtual threads, like we said, uh, okay, can you hear me? Okay. The virtual threads, like I said before, it was they are virtual, so they are not a really threads. They don't will execute the thread itself. The platform threads will execute the stack. The virtual threads just will hold the stack. So do you remember the stack that is a queue of a FIFO, that first in, first out? The virtual threads will just hold this stack, and the platform threads will execute these threads. But and then the platform threads will go to OS threads and will go to the CPU. But just to understand how the platform threads works, the platform threads will hold one virtual thread, and then when they go to the OS thread and execute it, they have a green sign of the CPU that was executing. They unmount the virtual thread. They will move this virtual thread to a queue of a block virtual thread, and then get another and execute it. So basically, we're gonna have they're gonna work like the executor service of the computed future, but this will be like a black magic for someone is using, because you're gonna see anything like you're gonna don't will touch on the code, but the way the handle of threads will work perfectly. Let's do the first example. So we have, for example, external query search that will take time, and the virtual threads will get the response and get to the next command, like this picture here. So we have the OS thread, that have the platform thread, that we have the virtual thread mounted. When the OS thread say to the platform, this is executing, they're gonna unmount that and move to the block virtual threads and get another. So you don't have idle time here. This is the good use, because we have a block where this block will happen. Like I said before, like API call, a database query, something that need external command that will take time. Let's show example. After that, if someone need to see the example, it's gonna be on the GitHub. I'm gonna show here how it's gonna work. So let's move it here to the IntelliJ. Okay. So here we have a sample application of a Spring Boot. On the Spring Boot 3. I think from 2.5, we have a new property that is calling Spring Thread Virtual Enable. By default, it's false. So by default, it's false, but you can set to true. This application is a totally simple application that will have a user model that will have handle some user data. We have a repository here to consulting on the Postgres. We have a Docker Composer to up here a Postgres on local machine, and basically it's gonna what they get our users gonna do for us. They're gonna thread sleep will simulate exactly API call, because API call basically will do a thread sleep to the thread, because they're gonna wait for 3 seconds. For example, we're gonna wait for 3 seconds here. And then you're gonna choose the repository and find everything. So let's first execute on the other way. For the tester proposal, we are limited to Tomcat threads to 8, because of course, if we need to show here the threads fully. If I don't limitate that, I will basically broken my computer. So this is not the case. So let's just limitate to 8 and see how things work. Let's up this application. Sure. So now let's execute a hey command. This hey command will do a 32 executions on the same time to the endpoint. Let's see what's gonna happen when you have a normal thread. See, we have 8 executions, then it's wait to the finish. So more 8 execution, it wait, more 8 and wait. And then we have the response. It took 12 seconds to execute everything. And we was able to see how the block happens. Basically, they execute the 8 first request, then the other is waiting until finish. After finish, they get the other 8 and execute. So we have an idle time for the CPU waiting for the finish of these 3 seconds. But what happened when you change to true here? Let's see. And let's execute the same command. Don't change anything in the code. See? We don't have more this blocking time. They execute everything basically in the same time. The response time was 3 seconds. Why 3 seconds? Because it was the blocking that I put here. The 3 seconds is the time that uh, takes to finish the thread. But when we block a thread, they get another virtual thread. Basically, let's go back to the presentation. This is exactly what happened here. That's exactly what happened. So when we finish, the virtual thread finished and it was blocking because we set the thread sleep. It's moved the virtual threads to block the blocking queue, and then they mounted other to not have idle time, but it's too fast, and we basically we don't see any time wasting on execution. But basically, is that what happened in what we saw? And on the old case, we saw the blocking, the time that waiting for get others executions. So this is the perfect use of the virtual thread. But why when this is not a good case? When you have a too fast operation, not a block I/O. For example, what is not a block I/O? In-memory operation. So basically, we're going to do aggregation. We're going to do, for example, I'm going to do a sort of a list. We're going to do a reduce, something that will use memory operation. They don't go to other third-party operation like database, API call, or other things that you can imagine that will request more time, or a block I/O, or read a file, for example. But this will take a time because it's need to waiting for some finish. But for example, on this example I'm gonna to show now, we don't have this wait because it's on memory operation. In a real time, a real case of use, we can imagine, for example, a real-time operation. Maybe you have a real-time operation that will just do aggregations on memory. Probably virtual threads don't will be a good case. But let's show this thing happening. We have a scenario here on the same application that is the bad use. But the bad use don't will block the query. We'll just do a reduce of a list will sum everything and return. So you don't have a real blocker here. So let's first see what happened on the old case. We're going to use the same way we did the test before. Let's use the hey. But you're going to call the bet using endpoint. As you can see, you don't have any blockers. So the execution was fast. And we didn't happen a waiting case. And the execution time was 0.14. Let's see with virtual threads. With the same endpoint. See, we have a little one, but it's not much. You do not change anything. Or sometimes, if you keep executing that, probably virtual threads will lose time, because in some of type of operations, virtual thread, because they have to managing the threads, managing everything, mount threads again, will take more longer than the old case. So virtual threads will not own much thing here. This is the bad scenario. Well, basically, guys, what is the conclusion about virtual threads? Virtual threads will help us a lot in case of what we have the most on the business scenario is API calls and the queries or blocking IOs case. So if you have application that do, for example, a BFF that is do a lot of API calls, or if you have application or a microservices that is consulting a lot of data from database, virtual threads is perfect to you. If you have, for example, a real-time operation that do a lot of aggregations in memory, that do a lot of things, this is not the case, because it's not will help you a lot, or probably don't help you anything on this type of applications. But the virtual threads came to help us to kind of bring Java close to languages like Go, like Node.js, that do a better managing of the resource. So virtual threads will help us a lot on this case. Right now, I'm gonna open to questions.
Great, great. Thank you very much for your presentation. Really interesting was to hear about virtual threads. Uh, so before we proceed with questions, just a small question from my side. So did you already have a chance to try virtual threads in production, and what were your experience from that?
I have tried on microservices before, and it was very good. I didn't have any problem on production. Of course, now that is not on preview anymore. We waited to exit from preview. So on Java 21, it's a final version. So it's safe to use on productions. Was a very good experience because we won a lot of time. It's not just I show example here that we won like more than 6 seconds of execution, but truly we won a lot of time on these executions. That is totally true.
Okay. Yeah, that's really great to hear, because I can say that on my project we plan migration for Java 21 only next year. So I really exciting about this migration to virtual threads, because we have a lot of stuff in written on Webflux. Obviously, you also mentioned that in your talk, and we have this question in. It's not a question; it's like, just a comment in our chat. So like, yeah, it was an alternative, but yeah, I'm really excited that we can remove all that stuff and write everything to virtual threads. Question from one of our listeners. In our experience, in order to really have the benefits from virtual threads, the code changes still might be required in your code or in the libraries to use. Example, to avoid thread pinning. So, what is your opinion? Are there like a lot of changes required for initiate virtual threads, or just some like small configuration changes?
No, but the changes is minimized by virtual threads. You don't need to change much things. Yeah, this is the benefits of the virtual thread. You might not require your code change, just libraries, and you just for if you're using, for example, Spring, you just need to update your Spring version, upgrade the Java version, and then set a property. Just that. You just need to do that to use virtual threads. It's too easily. I have experienced that we need to change, for example, to Webflux application that we change from Webflux to the application was for to a BFF, and we need to change from Spring Boot Classic to Webflux, and it was too hard because the people was a change of mind to everyone. So to everyone learn, everyone needs to do a course, need to do a learning time, take like 2 hours of the day to learning Webflux, and then we can change that. It was too hard and costly to the company. So virtual threads is much better on this case.
Yeah, yeah. Well, nice to hear. By the way, that's really impressive and really nice to hear that finally Java is like have some human face. So you not only need to like write a lot of stuff, but you also can just enable new feature. And sure, it should work. It should work. So guys, if you haven't tried it in Java 21 yet, I do recommend you to do that. Some philosophical question, right? So we always in Java conference have people from other stacks and they come and ask questions. So obviously in .NET, these thread syntax is really simpler. So they have async await and mostly the same we have in JavaScript, etc.
Yeah.
So question is kind of philosophical. What do you think? Will we ever have in Java syntax like that?
Oh, we should, we should. But if we think in Scala, Scala has a very easy way to handle that. And I saw on the older versions and the new versions of Java that we are giving a lot of features from Scala. For example, we have the now the vars, so the implicit variables that came from start from Scala and move to Java right now. On Java 11, we already have that. So a lot of features that is moving to that. I think on the future, probably we're going to have a keyword called async, and this become async. Of course, we have some features, for example, from Spring, we have annotation async, and we can bring that to async. It's not the a real async, but it's a start of it, you can say. It's not a no work like Webflux, but it's a start of it. I think in the future probably we're gonna have a Jeep that will say to create a keyword async and make everything async more easily. Probably or sync because need to be sync sometimes. We have a lot, of course.
Yeah, so as you mentioned that about this, not everything should be in sync. So for last, I think 5 6 years, as sorry, as Webflux and Reactive Stack is here with us, a lot of libraries and a lot of frameworks were adapting to this reactive stack. So we basically have now a lot of libraries like Mongo library or like Postgres library, like normal one and reactive one. And same for
Yeah.
mostly a lot of libraries. And now when we write code, we should always think about which we use and if we communicate correctly with database, if we communicate correctly with other service, if other service basically support reactivity, is front-end support reactivity with RSocket or whatever. So what is your opinion? When we all, I hope, hopefully we all will migrate eventually on virtual threads, would we have something same, or we finally would have something unified and we ease our life in use all of that? What is your opinion on that?
I think it's closed, but I don't think so. It's gonna be so fast. Like, of course, we got now virtual threads that will help us a lot with the black magic, so don't need to change nothing. But for example, for H2DBC, for example, is a very good tool to do async calls to database. But to have a unify of everything, I think will take a little time. But we're gonna have a help, for example, from Spring Boot, because if Spring Data will, for example, the Spring Data adopt that for just a property to use the sync or not, will be easily. So I think it's possible. It's possible, and the future is that, because we cannot just stay on a word that we just do sync. We need to move to async to use the better the resource, because we know that a lot of people that is playing about Java is the Java is low, the Java take much of memory, the Java is heavier because of that.
Yeah,
Because of
I
this
also
problem.
I wait for this time when we stop joking about that. Yeah.
Yeah.
So meanwhile, we have a question. Yeah, guys, just if you want to ask something, post it to the YouTube chat or chat on the community platform. So, question from Alexander: can we have virtual and all threads in the same project in parallel? Virtual for one endpoint, classic for another endpoint.
No, no, for the same project is impossible right now, because the application need to work with the JVM with the virtual thread management. So we cannot have one endpoint with virtual threads and another endpoint with another. Probably you're gonna need to split in two microservices, and one is with false for virtual thread, and one with true for virtual thread. But
To be honest, I
together
want
is
to
not
ask.
possible.
Yeah, thanks for answer. To be honest, I want to ask Alexander back why he wants to have this, because basically the whole idea of virtual threads is that we would substitute the normal threads and nothing would change.
Yeah,
So basically, the idea is that all threads are really heavy, and we have to connect them to operation system. I'm not sure if you remember. I'm too old that we have to calculate how many threads we can run simultaneously, and then
yeah,
thread executors come in place. So the whole idea of virtual threads, as we don't need to think about that. You just run thread, and it's there for you. So yeah, if you have real example why you need both type of threads at the same time simultaneously, so just tell us. Maybe it's really interesting, so we can
yeah.
discuss that.
Yeah, I was
Make
thinking here. I don't think so. We have a way to use that in parallel. I don't think so. Maybe he was thinking about we need a sync case, but it's not the way we think on Java sync case, because they not will handle, for example, maybe he was thinking on the parallelized paradigm, that if you run API call that will need the second one, will need the first one result, but the Java virtual threads will handle that for us. We don't need to handle, because of course, when we think JavaScript and we need to wait the first API call to call the second, we need to do a while or a for comprehension, something like this. But for virtual threads, we don't need that, because we have the stacks. Do you remember that? And the stack will be on the same application. So the virtual thread will handle the stacks, but it's not a parallel. That is the important thing. Maybe one thing we are, and this is a good case, it's opening in my mind right now, is virtual threads not paralyzing your calls. That is the truth. One thing that is important. That is
Yeah.
not paralyzing
Mhm.
your cows. They are just paralyzing your stack, not your cows.
Yeah,
Not
yeah, yeah.
paralyzing your code.
That's absolutely true. One more question from Carlos: would be any impact, positive or negative, when using completable future with virtual threads enabled?
Well, for sure they don't will have a positive. because the part 2 don't will change nothing. That is the truth. Don't change nothing because when you have using the computed future, they have the executor servers, and the executor server is a really a sync. So basically, if you move to virtual threads, they're gonna execute things as a sync too, but on the thread management, don't you change anything to you basically.
Yeah, just want to join Joao here. So all these completable features and async annotation in Spring, basically they are working on threads and they just ease the management of threads for you. So if you move to virtual threads, that would be basically the same. You will see the same functionality, but most probably it would be uh, more lightweight, I would say, and more easier for framework to work with that, and maybe easier for
Yeah.
resources. So definitely,
Exactly.
definitely have to try. Okay, I assume that's it with the questions. So, João, I want to say muito obrigado. Thank you very much for your
Thank
talk.
you.
Thank you very much, and hope to see you on other Java conferences. Thank you.
Thank you. Thank you for everyone watching. Bye bye.
Bye.